im se svima, i malima i velikima, i bogatima i siromašnima, i slobodnjacima i robovima, dade žig na njihovu desnu ruku ili na čela njihova, te da nitko ne može ništa kupiti ili prodati.
Pozdrav drage narode, dobrodošli u još jednu epizodu Slobodni. Klimatske promjene, to slušate svakodnevno. Naslovi vrište kako smo u situaciji da moramo podhitno nešto poduzeti. Kataklizma nam slijedi. Međutim, da li je uistinu tako? Danas moja gošća je upravo netko ko će nam objasniti polako, sa znanstvenog stajališta, hladne glave i stručno, čime se susrećemo i što je pred nama. Ona je autor knjige koja je upravo izašla, koja se naziva Klimatske nesigurnosti i rizik. Od sad nadalje ćemo razgovarati na engleskom. Hello Judith, welcome to our show in Croatia.
Hello, thank you for inviting me.
Can you say a few words about yourself and about your work?
Okay, I'm Professor Emerita of Atmospheric Sciences at the Georgia Institute of Technology, where I served as chair of the School of Earth and Atmospheric Sciences for 13 years. Currently, I'm president of Climate Forecast Applications Network. I've been conducting climate research for over 40 years. My company, Climate Forecast Application Networks, we predict severe weather events, and a particular expertise of mine is the climate dynamics of extreme weather and climate events. I've been involved in the public debate on climate change for almost 20 years, and I've looked at all of this from a very critical perspective, looking to put all these hidden assumptions that are being made out in the open and trying to promote open and honest discussion about this whole issue.
Great. That means that you are perfect for this topic. Okay, let's go straight. Is there a climate emergency as they are presenting us in the media?
Oh no, I mean, we have a slow creep of warming, and this is not an emergency in any sense. Climate risk has been badly mischaracterized. People are claiming that every extreme weather event, a flood or a heat wave or a wildfire, that this is caused by fossil-fueled warming. Well, it isn't. I mean, these kind of weather events have always occurred, are occurring now, and will occur in the future, no matter what we do with regards to our fossil fuel emissions.
What influence humans have on climate?
Well, the one that is most discussed is the burning of fossil fuels, which emits carbon dioxide, which acts to warm, and it also emits pollution particles, very small particles, which have an opposing effect, which act to cool. Humans also influence the climate locally through land use patterns, through cutting down forests, agriculture, paving cities over with cement, and so on. So, we do influence climate in many ways, but the underlying forces of climate variability are from nature.
And then what else has an influence on climate? Can you explain us everything what has influence, and also please just show us a few examples.
Okay, well, the sun plays a big role in climate variability on longer time scales. Anytime there's a big volcanic eruption, that can have a huge impact. But the ocean circulations, which are slow and very large scale on time scale, scales, short time scales like El Nino and La Nina, and then on longer time scales and even 1,000-year time scales, these ocean circulation patterns can play a big role on what's going on with our climate. As an example, in the early 1800s, there were 3 massive volcanic eruptions. The biggest one was Tambora. This was the year without a summer. It had a huge cooling effect on the climate for a decade. For the last 150 years, the volcanic eruptions have been quite tame. So if some of these big volcanic eruptions were to happen in coming decades, that would fundamentally change the course of our climate over the rest of the 21st century. During the 14th century to the 19th century, we were in the Little Ice Age, where temperatures were very cold, extremely cold in Europe. There were widespread famines, and this was caused by a combination of effects from the sun, a large number of volcanic eruptions, and also the ocean circulation patterns, which all conspired to provide a cold climate for a number of centuries. Around 1850, we started coming out of the Little Ice Age as the sun brought us into a more warming period. There were no big volcanic eruptions, and the ocean circulations patterns were favorable for warming. So there's a lot of things happening with the global climate that really don't have much of anything to do with human impacts.
There is also volcano Hunga Tonga in January of 2022. What was the impact of this volcano eruption?
Okay, well, Hunga Tonga was interesting because usually volcanoes have the biggest, they emit all these sulfate particles, small particles in the atmosphere, which get into the upper atmosphere and stay there for a long time. And these particles reflect the sun's radiation and has a cooling effect. Now, Hunga Tonga put a little bit of sulfate particles into the atmosphere, but the bigger effect, because it was underwater, it explosively ejected a lot of water vapor into the upper atmosphere. And this, in some ways, cancels out the reflective aspects of the sulfate particles. And it seems that the Hunga Tonga, this water vapor is having a bigger impact in the winter hemispheres, and we're seeing a significant impact this year in the southern hemisphere around Antarctica. We have the ozone hole opening up early. We're seeing anomalous wind patterns. We're seeing a lower extent of sea ice, and I think this is in part associated with Hunga Tonga. But in terms of an effect on overall global temperatures, it's not a huge one.
And what is the solar impact on climate? And can you explain us how?
Okay, well, the sun goes through, its own internal cycles of activity, and people are familiar with the 11-year solar cycle, when sunspots are higher and then they're lower, and this is fairly repeatable. There's also longer-term cycles and oscillations. In the second half of the 20th century, we were in a grand solar maximum, the highest solar activity that we've seen, for 1,000 years, and that almost certainly had some impact on the late 20th century warming. There's also a lot of indirect climate effects from the sun, some of which aren't very well understood and aren't included in the global climate models. So a lot of climate science is not paying enough attention to how the sun could be impacting our climate.
And can you tell us what means paleontological impact on the climate?
Well, paleontology is the study of, past climates. And so people use various proxies like ice cores and tree rings and sediment cores to make inferences about what our past climate was like. So it's not a direct influence on the climate, but it's a way we study past climates.
Okay, then we come to this internal decadal variations. There's some variations that we have to explain it here.
Okay, this is, in terms of these internal modes of ocean variability, it's like El Nino and La Nina, but there are these big, larger scale modes of variability tied to circulation patterns in both the Atlantic and the Pacific Oceans. And right now we're in a period of the warm phase of the Atlantic multidecadal oscillation and a cool phase of the Pacific decadal oscillation. And that combination is working to produce some bad weather, if you will. We've had a spell since about 2017 globally of a lot of severe weather events. And that's tied to the large-scale multidecadal ocean circulation patterns. It's not related to fossil-fueled warming at all.
Can you tell us something about the melting ice? They're already always mentioning that there will be elevating sea level because of melting of ice.
Okay, well, I mentioned that we started coming out of the Little Ice Age around 1850, and the glaciers on the land started melting during that period, and they were melting quite rapidly in the 1920s and the 1930s. And then all that slowed down in the 1940s and 50s, and then picked up again, say, quite a bit in the 1980s. And so as these land glaciers have melted, they've contributed a little bit to sea level rise. But you have to put this in a much longer context. 20,000 years ago, North America and Europe were under, huge ice sheets, okay, and that part of the ice ages, and then a lot of that melted and a lot of land glaciers were left. But there was a warm period around 8,000 years ago when a lot of the land glaciers disappeared, and then they started growing again. So there's a lot of natural climate variability that determines the land glacier ice. So sea level rise has been increasing since about 1950 at a slow creep, maybe about 7 inches per century, which, isn't particularly alarming. It's something we can adapt to. But the big concern is that climate models project, if there's a lot of warming from fossil fuel emissions, they're projecting maybe, several meters of sea level rise by the end of the 21st century. But there's growing evidence that those extreme projections of sea level rise are not justified, by anything that's, really happening in the climate. And they're also tied to extreme emission scenarios, the scenarios that the UN has created to drive climate models with a certain amount of emissions from fossil fuel burning. And those emission scenarios are way too high. And even the UN is acknowledging that those scenarios are way too high. And the worst projections, that we've heard about, in the last 5 years are really off the table, where even the UN is looking at more modest projections of warming over the rest of the 21st century.
Well, we'll come back again to these changes in weather, but let's now go to this administration. We have International Panel for Climate Changes. What is IPCC?
Okay, the IPCC, Intergovernmental Panel on Climate Change, was formed in the late 1980s to assess the possibility that we were going to have dangerous human-caused warming as a result of burning of fossil fuels. And the IPCC first assessment report, which was published in 1991, said, well, we haven't seen too much warming yet. There's no particular evidence of anything beyond natural climate variability. Well, that's not what the UN wanted to hear. The UN went ahead and implemented a big treaty in 1992, the UN Framework Convention on Climate Change, which was to prevent dangerous anthropogenic interference with the climate, meaning burning of fossil fuels. And 196 countries signed on to this treaty, including the US. And so you can see right from the beginning, the policy cart has been way out in front of the scientific horse. And so the IPCC, which started out in a reasonable way, if they were to continue to exist, they had to really focus on this issue of dangerous human-caused climate change and, focus on that, not talk about natural variability, not talk about any benefits from warming, but they were basically assigned to look for dangerous human-caused climate change. And each successive report became more alarming in some ways. I'll talk in a follow-up question. I can talk more about the most recent one, but they looking at a very narrow piece of this issue, focusing only on human-caused climate change and only on the potentially dangerous aspects of it. So we're getting a very narrow slice of the big picture here.
Yeah, we will come to this difference between danger and opportunity in the case of heating. Just let me mention, who are the members of this IPCC and what is their background?
Okay, the IPCC, the members of the IPCC Bureau, which is really the organizing committee, is the member countries of the UN nominate people, and then people from, then the UN basically selects, there's an election from the various members about who gets to lead these reports. And then once the leadership is established, the member countries nominate scientists from their country to be authors, contributing authors and lead authors to the report. So, and then the nominations are then selected by the higher level IPCC officials. So this is all sort of orchestrated to select people with a perspective that is going to support the policies of the UN Framework Convention on Climate Change, with all these treaties and emissions reductions and so on. So it's not an unbiased sampling of the world's climate scientists by any means.
It sounds to me like that it is more political than expert panel.
Well, there are most of the people on the IPCC are scientists, credentialed scientists, but all of they're selected to have a certain perspective. Yeah, politics is driving the whole thing from high levels, from the selection of the scientists to serve on this and the focus on dangerous human-caused climate change. That's all politics. But the IPCC authors, to some extent, particularly the Working Group 1 scientists who focus on the physical climate change, climate science, their big report is relatively unbiased, but the summary for policymakers, they cherry pick various things to make it look more alarming. And then in the press conferences held by the UN officials, they make all this even more alarming yet. So what the average person and the public hears about all this is carefully crafted spin, heavily politicized.
And what this assessment, report 6, is the last one, what is telling us?
Okay, the Working Group 1 report on the physical climate basis, which talks about the data and the climate models and stuff like this, this was actually a better report than, say, the AR4 and the AR5. They recognized that climate models were running too hot, and actually they downplayed the climate models quite a bit. They acknowledged that the highest emissions scenario were not realistic, even though a lot of their results were tied to these unrealistic scenarios. They acknowledged that the highest estimates of the climate sensitivity to increased CO2, that those numbers were too high. And so, they pulled back. They had better assessments of uncertainty. So there were a couple of things that were in the right direction in the Working Group 1 report. However, the Working Group 2 report, which is on impacts, was way over the top and was the worst Working Group 2 report that I've seen in a while, where, everything is caused by human-caused global warming, and they even claimed some things that were in contradiction with the Working Group 1 report and whatever. So, it's a mixed bag, but the UN officials, nowhere in these reports do they talk about a climate crisis, a climate emergency, or even dangerous climate change. They recognize that all of this is, a value judgment made by, people's perception of risk and by politicians who have a particular agenda. So science doesn't have anything to say about whether warming is dangerous or not. That all boils down to a value judgment.
Yeah, when you mention boiling, we just heard Guterres, who says that we are now transferred from the global warming to the global boiling. But we'll come to this later. Can you tell us how they assess a risk?
Well, they don't really. The IPCC doesn't really do a rigorous assessment of risk in the way that I understand it, where you look at, the pros and cons and all the different causes and the systemic aspects of the risk. The IPCC doesn't really do that. They assume it's dangerous. Okay, then they look for evidence of danger. And they say, use the precautionary principle, say we need to get rid of the fossil fuel emissions so we can get rid of climate danger. Okay, so it's not a real assessment of risk. In the Working Group 2 report on impacts, they go through all the weather-related problems in various countries. Oh, there's floods, and there's droughts, and there's famines, and there's hurricanes, and there's heat waves. And then they blame all this on human-caused climate change instead. But there's two issues. It's related to natural weather variability, and a lot of the problems, particularly in developing countries, are related to poor governance and poverty. So a lot of these really bad impacts are just social, not really caused by the climate. But it's such a convenient scapegoat whenever anything goes wrong. Like we're seeing this now with the terrible fires in Hawaii, where so many people were killed. it was natural weather event, but they're blaming it on, all of the bad impacts on global warming, neglecting to mention that they've had very poor land use policies with all these invasive and highly flammable grasses. They haven't been managing their electric power lines correctly. And also they had a warning system that just they failed to use. So this is why there was such a big loss of life. It had nothing to do with global warming. But nevertheless, you have the governor of Hawaii saying, oh, this was caused by global warming, help us. Well, using global warming as a scapegoat so people don't look at the poor policy and management decisions made by the elected officials in Hawaii.
Well, I had the opportunity to read one book. This book was published on the 10th of August, and this Hawaiian wildfire became at 8th of August. That means in a day when it's finished, they already published book, and I read it. And this book says it is obvious that artificial intelligence made this book. But in the start and the finishing of this book says that climate changes are responsible. And as you see, I recognize here propaganda, because it's not possible that man can investigate such a thing and make a book on a day and publish it in Amazon on a day when this wildfire is finished. And of course, conclusion put inside its climate changes. But anyhow, they are doing models. How they are making these models, what items they are using for that?
Okay, global climate models are exceedingly complex numerical models that are solved on a computer. They have equations based on physics mostly to predict the circulation patterns in the atmosphere and oceans, the temperatures. They have land surface modules that looks at vegetation. They have ice sheet modules that looks at the changes in the ice sheet, and these climate models run on the largest computers that are available. So it sounds pretty important and pretty sophisticated, but the issue is we're talking about two chaotic fluids, the atmosphere and the ocean, which are quite unpredictable and interact in even more unpredictable ways, that the climate really isn't predictable on what they're trying to do, and they force it externally with adding CO2, carbon dioxide to, and they see warming from the climate models, but you can do those calculations on the back of the envelope. At the end of the day, these big global climate models aren't useful for making predictions. They don't correctly simulate the regional variations of climate. And I think there's growing realization, even by the IPCC, that these global climate models are of limited use.
What kind is plausibility of this data on the basis where they're making these models? And also what is important, according to this data, how many models they can make? I read it in your book that even 81 results can come from this combination.
Yeah, there's maybe 25 different international centers that have developed climate models, and these climate modeling centers develop different versions, one which may adding different things, one which may add a lot of atmospheric chemistry so they can explore that. Another one may be making a very high resolution ocean model so they can explore that. And so there's all these different possible combinations of things that you can do. You have to make compromises because the computers just simply aren't big enough to model this correctly, even if we knew how to model it correctly. So there's a lot of different solutions. Some of the models are very sensitive and produce a lot of warming, and some of the models don't produce much warming at all. The model that produces the least amount of warming is the Russian model, and climate scientists tend to dismiss that model. Oh, it's too low, but I think that's a pretty interesting model that may be closer to reality.
Whenever they come out in public, they say that there is a scientific consensus about climate changes and human impact on climate. Can you explain us what they mean by scientific consensus?
Okay, well, they're misusing the term scientific consensus. A scientific consensus is about things that there's no controversy about. We all understand it. The Earth orbits the sun. I mean, that's an established fact. We don't even need to talk about consensus or something like that. Okay, what they're talking about is really a consensus of scientists, which is scientists getting in a room and agreeing to something. After the first IPCC assessment report, the leaders of the IPCC says we need to make our reports represent a consensus of scientists. So it's a manufactured consensus. I mean, the knowledge base about climate change is not sufficiently established by any sense to have a real scientific consensus. Rather, we have a politically manufactured consensus of the IPCC scientists. And because of the authority from the UN and the vociferous way in which the IPCC consensus is portrayed, other scientists sort of join in. Yes, we support the IPCC consensus, without really, understanding in detail the climate dynamics behind the so-called consensus of scientists. So it's very different. It's a political consensus, if you will. It was sort of mandated by the governments, like, we want you to reach consensus, and it reflects a way of grappling with the horrendous uncertainties and sort of taming them in a way that policymakers can go ahead and make decisions. But it can be very, very misleading to policymaking if you're manufacturing a consensus and you're hiding the uncertainties. You could really be making some big mistakes, which I think they are.
Well, let's say it simply. It's not scientific consensus, it's consensus of scientists. But who has impact on this scientist will go through it. Is it that they have too many confidence when they are going publicly and make a statement?
Oh, overconfidence for sure. They are highly confident. And the IPCC report, they have these confidence levels, low, medium, high. And even their medium confidence level reflects, significant uncertainty and disagreement in medium confidence. Well, I would say if there's significant disagreement and uncertainty, I would call that low confidence. So there's explicit confidence inflation, even in the IPCC reports. But then the media and the activists even go far beyond, with the crisis and absolute narratives of catastrophe and apocalypse. And there's just simply no scientific support for that, even in the IPCC reports.
Then let's go through it. What we indisputably know, what is for certainty, what with the less certainty, and what there is no chance to happen.
Okay, what we know with certainty. First, temperatures have been increasing since about 1850. Nobody disagrees with that. We are emitting carbon dioxide into the atmosphere by burning fossil fuels. Nobody disagrees with that. Carbon dioxide emits in the infrared, which helps keep the planet warm. Okay, these are, the basic facts that nobody disagrees on. However, those three facts do not tell us anything about the most consequential issues, such as how much of the warming, recent warming, has been caused by fossil fuel emissions versus natural climate variability. It doesn't tell us whether warming is dangerous. It doesn't tell us anything about what's going to happen to the climate in the future. And it doesn't tell us anything about whether rapidly reducing fossil fuel emissions will overall benefit mankind. So all these most consequential issues, remain deeply uncertain, associated with plenty of disagreements. And then there's stuff that, what I would call known unknowns, things that we know we don't understand enough about. We don't understand the solar indirect effects. We don't understand enough about ice sheet dynamics, particularly the Antarctic ice sheet. We don't know enough about how the oceans store carbon. We don't know enough how the land and plants respond to increased carbon dioxide. A lot of uncertainty, quantitative uncertainty in the carbon budget. We don't understand how to predict these multi-decadal ocean oscillations, which are critical for understanding regional and decadal scale climate variability. I mean, these are a lot of the known unknowns, and then there's other things that are more speculative. Okay, another one is the geothermal heat, the heat from beneath our feet, particularly in the oceans, underwater volcanic eruptions. We've probably been underestimating that impact, and there's also even volcanoes beneath the West Antarctic ice sheet, which is maybe contributing to its potential instability. There's so many things that we don't know. We also don't understand quantitatively how particles in the atmosphere, some of which are emitted from fossil fuels, others which are natural, how these change cloud properties and which changes how much solar radiation from the sun get reflected and influences their formation properties. So there's so many uncertainties, and many of these are acknowledged in the IPCC assessment reports, but they still come back with these highly confident conclusions, which simply aren't justified in the face of all these uncertainties.
Can you tell us something about local climate specifics? Because global warming exactly on a local level is not a bad thing. Even there have some advantages.
Oh, sure. I mean, look, if you're in Canada or in Siberia or northern China, I mean, some warming could, make your location a lot more hospitable and support agriculture. So there are some regions where warming, would be very beneficial. But locally, let's say in the mid-latitudes of the Northern Hemisphere where many people live, their local weather is determined more by these multi-decadal ocean circulations, which influence regional weather and climate, and also by local land use, whether you've cemented over your city. In the US, Phoenix is a city in the Southwest, which is in the desert. It's very dry and it's very warm. And they've had some insanely hot temperatures this summer, but it's estimated that about, particularly at night, about maybe 12 degrees Fahrenheit of that is associated with the urban heat island effect, the fact that they've cemented over this whole region and it's retaining so much more heat. So, we do influence our local climates a lot by how we use the land. But, most people, if it wasn't for all this hype about global warming, I don't think people would particularly be aware, that the climate is warming. It's been a very slow creep. Sure, it's warmer now than it was in 1950s when I was born. And I remember, a lot more thunderstorms growing up and maybe less thunderstorms now. But I live in a different location and there's different ocean circulation patterns. There's so much variability that if people weren't talking about human-caused global warming, people would, just think of climate variability as a curiosity and something interesting and maybe something to be adapted to. There wouldn't be all this panic about, completely changing our energy infrastructure in a futile attempt to control the climate.
Well, even in some areas, it's even better when you have more, for example, in areas where you have monsoons, if you have more water and more heating, you have a better impact on agriculture.
Yeah, to the extent that you believe the climate models, they predict that there would be more warming, more water and more rain in the South Asian monsoon regions. And that region is seriously water stressed and with rapidly growing population, so more water would be very welcome to them. This is a tough year for them. The monsoons aren't very good this year, but that's a region that could use more water, which is expected in a warmer climate.
What we know about Atlantic multidecadal variability?
Oh, that's a big research area of mine. Okay, so during the Atlantic multidecadal oscillation sort of varies, goes through sort of a cycle, an oscillation on the time scale of 60 to 80 years. And we've been in the warm phase of the Atlantic multidecadal oscillation since 1995. And the most visible impact of that has been an increase in Atlantic hurricanes, but it's also influenced the shrinking of the Greenland ice sheet a bit, and also a shrinking of the Arctic sea ice extent. Now, we can expect a shift to the cold phase. It's hard to predict, but it could happen, in 5 to 10 years, and we would see some of that reverse. We would see quieter Atlantic hurricanes, we would see more accumulation on the Greenland ice sheet, and we would see the Arctic sea ice with, some greater extent. And this occurs on top of the slow creep of global warming, but it changes the precipitation patterns in Europe and Eastern North America, and it's a pretty big control on what happens in with our weather and climate, and that this can change, and it will change at some point. It's hard to predict. So when you're talking about what's going to happen, say the next 10, 30 years, which is when a lot of our decisions are made, there's a lot of factors in play that make me think, we'll see some relative cooling from natural forces, which is on top of the global warming from CO2 emissions, which would cancel things out. We can expect to see less, forcing from the sun than we saw in the late 20th century when we had that grand solar maximum. In the 20th century, we saw very low volcanic activity. Any increase back to the normal would have a cooling effect. And also, a shift to the cold phase of the Atlantic multidecadal oscillation would have a cooling effect also. So, thinking that we're just going to see this straightforward increase of temperatures from CO2 emissions is neglecting the possible scenarios, very likely scenarios of natural climate variability, which will probably dominate out to maybe 2050 before we would really see much of effect from the overall warming trend. And people are just ignoring this.
What do we know about Pacific decadal variation?
Okay, Pacific decadal variability is in many ways more complex. There are several modes. Right now, we're in the negative phase of the Pacific decadal oscillation, which makes La Nina events more likely. In the past 5 years, we've had 3 La Nina events, which is a lot, and that's characteristic of the Pacific decadal oscillation. Again, that influences water resources, hurricanes, marine heat waves, a lot of different things that are influenced by that. But it has a huge effect in the U.S. It has a huge effect on the weather and climate in the U.S. West, and of course it has a big impact on the weather and climate of the Philippines, Japan, and so on. So, these are big influences on regional climate variability on time scales of decades.
Climate policies are focusing mostly on temperatures and decreasing concentration of CO2. Is this the most important parameter to make model or assumptions?
Well, this whole idea of reducing CO2 emissions to decrease global temperatures is a futile one. It presupposes that we can control the climate on any meaningful timescales by eliminating CO2 emissions. This is a joke. Even if we were successful at completely eliminating CO2 emissions, we probably wouldn't notice any difference in the temperatures or the rate of sea level rise or anything like that until the 22nd century. So this is really a fairly futile exercise, in my opinion. Not that we should endlessly dump stuff into the atmosphere, but we should, there's no urgency to really do this. Over the course of the 21st century, we would probably naturally be transitioning to cleaner fuels, as fuels that are more abundant, cleaner, more inexpensive. Let's see where the technology leads us. But this artificial deadline of having to eliminate emissions, and the only way we can do this is with wind and solar, is a disaster waiting to happen, and it's a huge step backward for human development, in my opinion.
Well, we will come to this also.
Nitko vas neće natjerati da se poklonite zvijeri, učinit ćete to svoje voljno, odbacujući vjeru. Bićete laka meta za zvijeri, jer se niste podredili vjeri. Ako se ne podredite vjeri, podredit ćete se zvijeri. Toliko ćete se suobličiti sa ovim svijetom, da nećete ni prepoznati da ste u zabludi. Biće to najveća demonska prevara ikada i pravedno zaslužena osuda nad nepokajanim grešnicima.
Gdje su svi oni koji su